So we're going to start reviewing transformation rules. If our original function was y equals f of x, then the function y equals a f of b times the quantity x plus c plus d has been transformed based on what those letters a, b, c, and d each represent. So we're going to talk about what each of those letters represents. So the a in the front of the entire function represents a vertical stretch or shrink by a factor of a. It's in front of the whole function, so it affects the y values. And in fact, if we have a negative a, it becomes a reflection over the x-axis of the function. And this one pretty much makes sense. If a is a positive 5, it's a vertical stretch by a factor of 5. If a is 0.5, it's a vertical shrink by a factor of 0.5. The b in our equation, which is right in front of the quantity x plus c, is a horizontal stretch or shrink by a factor of 1 over b. Remember, factors that have to do with the x values, which is what is affected here, tend to do the opposite of what we expect. So if that b was a 2, it would represent a horizontal shrink by a factor of a half, not a stretch by 2. If b is negative, it would be a reflection over the y-axis. The c part of our equation, which is always in the parentheses along with the x, is a horizontal shift left or right, and it affects the x values. A positive c moves the x value to the left, and a negative c moves the x value to the right. And finally, when we look at d, which is in the end of the equation, that is a vertical shift up or down. A positive d moves the y value up, and a negative d moves the y value down. Hopefully you will remember all these rules as you look at different functions. Let's give you an example of one very easy function to look at. So suppose my function is f of x equals the square root of x. And I know that a sketch of this function looks like this. And there's the square root of x. And if I wanted to do a very simple transformation like f of x equals the negative square root of x, I am negating my y, which means I am doing a reflection over the x-axis, which means that my picture would go like this. And obviously if you had several transformations going on at the same time, your picture would look more complicated. So let's do a really complicated one. Negative 2 square root of x plus 4 minus 3. So if you recall from last year, we would start with 3 very obvious points from our original function. I picked 0, 0, 1, 1, and 4, 2. And we would do our transformations from the inside out. So the x plus 4 meant that I was shifting the x values to the left 4. So that's what I did in this first set and got negative 4, 0, negative 3, 1, 0, 2. Then the negative 2 in front of the function means that the y value was both negated and vertically stretched by 2. That gave me the points negative 4, 0, negative 3, negative 2, 0, negative 4. And then finally the whole picture was shifted down 3 in the y direction, which gave me the points negative 4, negative 3, negative 3, negative 5, and 0, negative 7. So my resulting graph looks like the picture at the right.